Okay, well, this is just to make sure that we can support that claim that a baby weighing 8.9 pounds is one standard deviation above average. Well, if the z-score is the number of standard deviations from the mean or from the average, then the z-score should tell us how many standard deviations this is away. Well, let's plug it in and let's see. We're going to calculate for z. The x value that I'm talking about right now is 8.9. Okay. The mean of this data is 7.6, and the standard deviation that we've come to know, according to this problem, that we calculated in the past, is 1.3. So how does that show us and prove to us that the standard deviation or the z-score is 1, or that this value is 1 standard deviation above average? Well, subtract those, you get 1.3. You divide by 1.3, you get a 1. So the z-score is 1, and that signifies that it is 1 standard deviation above the mean. We already said that 9 is a little more than 1 standard deviation above the mean. Well, let's see exactly how much. Calculate z. You've got 9 now. The value that we're talking about is the 9. If we subtract 7.6 and divide by 1.3, now we're looking at a number, shuffle, shuffle, that is this is going to be 1.4, and I'm going to divide that by 1.3. So 1.4 divided by 1.3, that's equal to 1.076. Usually we will round these to 2 decimal places. It's important that we understand it's 2 decimal places and that it's not a 1.07. Okay? You will lose points if you call that 1.07 and lazily ignore this number 6 here. If the number beyond the second decimal is 5 or above, you need to round it accordingly. Okay, so my z-score in this case is 1.6, 1.08 standard deviations above key average. Okay, so we're going to do the same thing with a couple more of these. We looked at 11 the other day, and we said, "Whoa, 11 is kind of surprising." Well, let's calculate it for 11 and maybe for 3.2, and then we'll call it good. So z is equal to 11 minus 7.6 over 1.3. 11 minus 7.6 is something in the neighborhood of 3.4, I believe. Yes. Okay, so 3.4 over 1.3. Well, 3.4 divided by 1.3 is going to equal 2.615. So what I would have you write is 2.62. You're rounding to 2 decimal places, and you'll see why in just a little bit here. But that's how many standard deviations above average an 11-pound baby would be. Okay, now we know because of the empirical rule, that means just the fact that he's more than 2 standard deviations means he's somewhere in the 2.5% range. Okay, the fact that he's well above 2 means you're looking at 1% or less of the population is going to have a baby that big. Well, here's a little baby. Okay. 3.2. Let's see what happens here. It's the first time we'll look at something like this, and you'll see what I mean in a second. Minus 7.6. So 3.2 minus 7.6 is equal to a negative 4.4. Well, wait. It's a negative. Is that a problem? I don't think so. I'm running out of space here. Negative 4.4 divided by 1.3 is going to give us a negative number. It's going to give us this number. Negative 3.38. One might argue, wait, shouldn't I round that to make that a 5, to make that a 9? All we are concerned with right now is looking to the right of that number. Okay, so that number can remain an 8 because to the right of it is a 4. Okay, so anyway, that's a negative 3.38. What that basically means is we are 3.38 standard deviations below average. The negative is important. It should be relatively obvious. I mean, this is a small number, and it's less than average. Our average of 7.6, so therefore it shouldn't be a surprise it's below. It's surprisingly below average, though, because it's more than 3 standard deviations. That should really raise our eyebrows, and we should hope for the best for this baby.